Hello and welcome. Today, we're diving into a significant achievement in artificial intelligence from Google DeepMind.
Okay, so let's dive into this incredible story of how an AI didn't just learn to play a game, but actually conquered one of the most complex, strategically demanding games ever made. For decades, AI researchers have used games as their ultimate proving ground. First it was checkers, then chess, then the ancient game of Go. But with each victory, the community looked for a bigger, tougher challenge, one that really mirrored the messy, fast-paced, and frankly confusing nature of the real world. And one game stood out from all the rest. And that game was StarCraft II. This was no simple board game where you see everything. Nope. This was a massive, real-time universe, specifically designed to push the human brain to its absolute limits in ways no AI had ever come close to handling. And look, this wasn't just some random pick. The AI community itself, the very scientists and engineers building these systems, all agreed. They reached a consensus that if an AI could crack StarCraft, it would be a monumental leap forward for artificial intelligence.
So what exactly makes it so tough? Well, it's not just one thing. It's everything, all at once. You've got this constant game of rock, paper, scissors, where every strategy has a counter. Then there's the fog of war. You have imperfect information, so you're always guessing what your opponent is doing. A decision you make right now might not matter for another 45 minutes. And it's all happening in real time. No turns, just constant action, managing hundreds of things at once.
To really wrap your head around that complexity, just look at this number. At any single moment in a game, there are roughly 10 to the power of 26 possible things the AI could do. That's a number so vast it's hard to even imagine, and the AI has to navigate that maze of choices constantly, second by second.
So, faced with this Everest of a challenge, how did the team at DeepMind even begin? How do you start teaching a machine to think on that kind of level?
Well, the answer was AlphaStar. And we've got to be really clear here. This was not a bot with a bunch of pre-programmed rules. This was a deep neural network, a true learning agent that was trained by watching and playing the game, pretty much the same way a person would.
Its journey started basically by going to school. In the first phase, it learned through imitation, just watching thousands of games played by humans to pick up the basic strategies. And this student version was already pretty good. It could beat the game's hardest built-in AI 95% of the time. But that was just kindergarten.
Because here's the thing. Just copying what good players do can only get you so far. To beat the best players in the world, AlphaStar had to stop imitating and start creating. It needed a whole new kind of training ground to evolve.
And to do that, the researchers came up with a really brilliant idea, the AlphaStar League. Just imagine this, non-stop internal tournament with a whole population of different versions of AlphaStar playing against each other, 24/7, learning and evolving. This whole setup created a kind of digital survival of the fittest. As soon as one agent got good with a certain strategy, other agents would immediately start training to find a way to beat it. This forced them to constantly discover new, creative counter moves, while the weaker strategies just died out. It was like cramming years of human strategic discovery into a hyper-accelerated time frame. And when I say hyper-accelerated, I mean it. Each one of those agents in the league packed in the equivalent of 200 years of non-stop StarCraft gameplay. And they did it in just 14 days. That's a level of experience that no human could ever match.
And the results? Well, they really speak for themselves. The initial agent that just learned from humans was pretty good. But the agents that came out of the crucible of the League, they made a gigantic leap, achieving Grandmaster level skill. That's the highest rank you can get in the entire game.
All right, so AlphaStar had been trained, it had been forged in the fire of its own league. Now it was time for the final exam. A head-to-head showdown against one of the best human players on the entire planet. On December 19th, 2018, the match was on. You had AlphaStar, with its 200 years of compressed experience. And in the other corner, Grzegorz Mana Komenchek, a top-tier pro player. Now, to keep things fair, AlphaStar's clicking speed was limited to a human-like level. The stage was set for a full professional series.
And the final score was unambiguous. A clean sweep. AlphaStar beat Mana 5-0. It was, without a doubt, a landmark moment for artificial intelligence.
But listen to what Mana said after the match. He wasn't just beaten by a machine with faster reflexes. He was impressed that AlphaStar played with a very human style, using advanced tactics and strategies he didn't see coming. In other words, he was outthought, not just outclicked.
Okay, so a really important question came up, and it's a fair one. The version of AlphaStar that beat Mana could see the whole map at once, kind of like a zoomed-out blueprint. A human player has to move a camera around to see what's happening. Was that the real reason it won?
So the team put it to the test. They trained another version of AlphaStar, but this time they forced it to use a camera, just like a human. And guess what? This new agent was almost just as strong. That proved the victory came from its brain, its superior strategy, not from having superhuman eyes.
So when you boil it all down, this whole project isn't really about a video game. The principles that let AlphaStar win have some really profound implications for solving problems way out here in the real world.
Just think about it for a second. The ability to make smart decisions over long periods of time using incomplete, messy information, that's the core challenge in things like climate modeling, weather prediction, or even understanding language. The techniques developed here could be a total game changer for those fields.
And this really gets to the bigger picture. This league-based training, where AIs are constantly trying to find weaknesses in each other, is a fantastic way to build safer, more reliable systems. It automatically finds all the weird edge cases and gets rid of fragile strategies. And that's absolutely crucial if we're going to use AI for important real-world tasks.
You know, mastering the strategic chaos of StarCraft wasn't just about winning a game. It was about building an AI that can handle imperfect information and long-term planning. And that's a massive step towards creating intelligent systems that can help us solve some of our own world's most complex problems. So it really leaves you wondering, if it can conquer this, what grand challenge is next?
Don't forget, like and share to spread AI knowledge.